Welcome to the online training, Water Well Construction, What Do I Need to Know? It is provided to you by the National Groundwater Association with support from the U.S. Environmental Protection Agency. This training takes about 15 minutes. The time you invest in it could protect your drinking water quality and your health. Make sure to take the quiz after you finish to see what you've learned. Going back thousands of years, people have built water wells to access life-giving water. Over the centuries, well construction techniques have evolved from ancient hand-dug wells to modern drilled wells. A modern drilled well starts with a hole bored into the ground and may include features such as casing installed in all or part of the borehole to prevent collapse of the borehole walls, a pump and pipe through which the water moves to the surface, various types of sanitary seals to prevent contamination from entering the well, such as a well cap, pitless adapter, and grout to fill the space between the outside of the well casing and the inside of the borehole. Various types of technologies are used to drill modern household water wells depending on the geology. Common methods include air hammer, air rotary, cable tool, and mud rotary. Knowing the role of key water well components is important to understanding a modern water well. The cap closes off the casing to prevent contamination from entering the well from the top. A sanitary well cap is bolted and sometimes locked to prevent it from getting loose or coming off. It is also watertight and has a fine screen-covered vent opening. Well screens are installed mostly in sand and gravel aquifers to filter out excess sediment, sand, or other particulate as the water flows through. Well screens are threaded onto the well casing. Pitless adapters provide a sanitary frost-proof seal between the well casing and the water line to the house when the line is installed below ground. Well pumps are the heart of a well system, pumping water out of the well and into the distribution system. A submersible pump is housed down in the well and uses a stack of impellers assembled on a shaft connected to a submersible motor. Submersible pumps are used in relatively deeper wells. A jet pump is a centrifugal pump housed above ground and used in shallower wells. In planning a well, there are some key considerations. One such consideration is location. When possible, wells should be located at higher elevations than the surrounding areas to lessen the potential for contamination from surface runoff. A well's location often will be determined by factors other than the subsurface properties, such as the contours of the land, power lines, underground utilities, trees, and the potential route for the water line to the house. In general, the following minimum distances from potential contamination sources should be maintained from the wellhead unless state or local codes or regulations call for more stringent standards. 200 feet from a cesspool receiving raw sewage or from a landfill or garbage dump, 50 feet from a pit, privy, filter bed, septic tank, tile sewer, or foundation drain, 20 feet from the outer boundary of any road, 10 feet from an iron sewer with approved mechanical joints, 5 feet from a property boundary, and 2 feet from a pump house floor drain. Another important consideration in planning a well is determining your water demand. To some degree, the geology beneath the ground surface indicates how successful you may be in obtaining a sufficient water supply. To determine how much water you need may take some calculations, including estimating everyday use such as drinking, cooking, and plumbing involving toilets, bathtubs, showers, automatic washers, dishwashers, and other water-using appliances, seasonal use for lawns and gardens, car washing, pools, and other outdoor purposes, other special uses such as animal watering, crop irrigation, and water treatment device backwashing, and fire protection use in those infrequent cases where another surface water storage option is not available. Three other factors should be considered when determining how much water is enough. First is the flow rate, which is the continuous rate of yield for a well. A low flow rate may require additional water storage to meet needs. Second is the size of the well, that is, the diameter and depth of the well. These determine, in part, the water storage capacity within the well itself. And third is the static level of the well, that is, the level at which water stands in a well when no water is being pumped. This also helps determine the storage capacity within the well itself. Here's a review question. When possible, wells should be located at higher elevations than surrounding areas. True or false? The answer is true. As a general rule, when possible, locating the well at higher elevations lessens the potential for contamination from surface runoff. Here's another review question. If a well is constructed properly, it should be resistant to contamination. True or false? The answer is false. A properly constructed well can keep some contamination out of the well water, such as bacterial contamination entering through a construction deficiency. However, if contamination reaches the aquifer from which you are drawing water, well construction cannot prevent it. The wellhead should be located minimum distances from certain contamination sources to lessen the chances of contamination reaching your water supply. Many state and local governments often prescribe these minimum distances. There also are some steps to finding a qualified water well system professional. First, if your state licenses water well contractors, make sure the one you use is licensed. Second, ask the contractor what records he will give you upon construction of the well. Records such as a well log and well construction report can provide important information in the future if your well needs maintenance. Third, ask the contractor if he has adequate liability and workers' compensation insurance to protect you. Fourth, ask the contractor for references from previous customers. And fifth, ask the contractor for a written contract specifying the terms and conditions of the job. Regarding contracts, typical elements of a thoroughly written contract for installation of a well system may specify liability insurance coverage held by both the owner and the contractor, that all work will comply with applicable regulations and codes, the diameter and thickness of the well casing used, the type of well development and yield evaluation procedures used, the type of screen installed, the type of well cap, the disinfection procedures used, and cleanup procedures, including all material abandoned at the drill site. Guidelines for written contracts also may specify the anticipated start date, a guarantee of materials and workmanship, that the contractor will do the work and correct the initial work if necessary, itemization of charges including drilling per foot, casing per foot, other materials such as the drive shoe, grout, and well cap, other operations such as grouting, developing, test pumping, and disinfection, drilling deeper and/or drilling a second well to ensure an adequate water supply, and abandonment and sealing of a well should it prove necessary. Here's a review question. To determine what a household requires from a well system to meet water needs, one should consider A. Everyday use such as drinking, cooking, and fixtures or appliances connected to plumbing. B. Seasonal use of water, such as for lawns and gardens, car washing, and pools. C. The rate of water flow into the well. D. The diameter and depth of the well. E. All of the above. F. A and B. And G. C and D. The answer is all of the above. Water use, the rate of flow of water into the well, and the storage capacity of the well system all can have a significant impact on whether a well system is sufficient to meet the household's water needs. Question: which of the following would not be typical of a thoroughly written contract for installation of a well system? A. A maximum cost ceiling for the well system. B. Proper liability insurance coverage to protect both parties. C. The type of well system components to be used. D. The type of disinfection and property cleanup procedures to be used. And E. Itemization of charges for materials and services. The answer is A. While a responsible water well system professional may provide an estimate of the cost for installing a well system, the contractor cannot always know what will be encountered with drilling into the subsurface. A well-written contract, however, will spell out what can be spelled out with certainty in terms of materials, services, and charges. Here's a final review question. A key question or questions to ask in seeking a qualified water well system professional include: A. Is the contractor licensed or authorized by the state to install well systems? B. Does the contractor have adequate liability and workers' compensation insurance to protect you? C. Will the contractor provide a written contract? D. Will the contractor provide you with a construction report, well drilling log, or any other records? E. Will the contractor provide references from previous customers? F. All of the above. And G. A through C. The answer is all of the above. In addition to licensing, adequate insurance, and a written contract, having a construction report and a well log provide important information that could be useful in the future when it comes to maintaining your well system. Also, a reputable contractor should be able to provide references of previous customers. To learn more about how to approach treating your water, visit www.wellowner.org and take our online lesson, Treating Your Water: Contaminants that Present a Health Risk or Other Problems. For more information on water treatment technologies, visit the National Sanitation Foundation's website at www.nsf.org. NSF is an independent product certification lab that tests and certifies home water treatment systems. You also can visit the Water Quality Association at www.wqa.org. The Water Quality Association has an independent product certification lab that tests and certifies home water treatment systems. Go to www.wellowner.org to find out more about useful private well owner information tools, including the Private Well Owner Hotline at 855-420-9355, the Private Well Owner Tip Sheet, a monthly email of helpful water well tips available through wellowner.org, more online well owner lessons, and upcoming free well owner webinars.